Right, today's project is going to be a field strength meter. As you can see there, the meter Mark II. Right, as you can see here on the display, it's very important to get yourself familiarised with the layout and the construction of the kit. So what we've done here is gone through the parts that were supplied in the kit, and we've checked them off against the parts list, and we've also gone through and checked that they are in operating condition. Now what we're going to do now is just show you some of the test methods that you can use. So the first component that we're going to test is a resistor. Now we've actually tested all these resistors, but we'll just go through the process. This one here is brown, black, brown. So you got 1, 0 times 1, so that's 100 ohms. Now if we put that onto the multimeter, we should get 100 ohms. We've got this on our resistance testing. So we put it on 200 ohms, and we're reading 99.6, which is close to 100 ohms, due to the tolerance rating of that resistor. Another way that you can quickly check what the colours are supposed to represent on your resistor, and there's plenty of apps available to do this, and this is just one of them. This is a 3-band resistor, so we've selected 3-band. We can pick our colour, so brown, black, brown, and you can see here it comes up with 100 ohms. So we're going to test one of the LEDs. We actually tested all these LEDs. The cathode is the short lead, and the anode is the longer lead. And this is a little test setup that we made earlier. And if we hold that on there, it'll come up, and you can see that the LED is working. You can see the brightness of the LED. Next component we're going to test are the diodes, and we've done this earlier with all of them just to make sure, but it's just to run you through the process. We've got the meter set for diode testing, and we put it onto our meter. You can see it tells you how it should be connected, and it gives you a reading 773, which basically means that's a silicon diode. This is just one of the transistor types. There's 2 types. But just to give you an idea, what I've done is I've gone online, I've looked up the right data sheet for that transistor. That now gives me the pin out for the transistor. As you can see here, I've connected up one of the transistors for testing. This particular test box just tells you whether it's NPN, PNP, etc., and if it's working. So I switched it on, I pressed the test button, and the light will come on, and it's telling me that it's an NPN transistor and it's operating. Again, another test that we can do for the transistors is to basically check the transistor to see if it's operating properly. As you can see here, we hooked it up onto a slightly different meter. We turn that to on, NPN because it's an NPN transistor, and we do test, and you can see it gives me a reading of 0.6 on the scale there, which is basically telling me it's operational and it's a silicon NPN transistor. Right, this is just another way to test the transistors, and this is a little bit more true than the other 2 methods, but they're basically indicators that a transistor is working or not working. We've got this set on transistor, we've got the drive set to low, and we're in auto mode at the moment, and we're checking NPN transistor, which is what this particular transistor is, and it's coming up as good. Alright, we're now switched to DC parameters for the transistor, and as you can see here, we're measuring the HFE, and that's on times 10 for the range, and we'll get a measurement of about 33, 34 times 10. If we go to a leakage current, put that on times 1, and you can see there's really no leakage, so that's your ICO. And if we look at the base emitter voltage, you can see there that it's measuring as a silicon transistor. So what we're going to do now is start putting the components onto the board, the printed circuit board, and there's probably more than one way to do this, but I find the easiest way is to put the resistors on first, so we orientate them all the same way and in the right place, and then after that we'll start putting the diodes and transistors on. Here we've mounted the majority of the components that go onto this printed circuit board. Now the approach here was basically putting on the smaller components like this small diode here, and then the flatter resistors, the smaller capacitors, and then we started working our way up to the higher profile components like the resistors here, the transistors, etc. We put the variable capacitor in here for the dial, and there's still a little bit of soldering to go on the top of that, and we'll put this junction wire in, which is going to be a new system to the original. Alright, so what the original concept was two lithium batteries being placed here, and underneath the lithium batteries was two wires being soldered on, and they were actually the negative contact for the battery. And then you had two wires going over the top for the positive contact of the battery. Now that's all well and good, except for if you need to change batteries, etc., then you've got to unsolder these, remove the batteries, put the new batteries in, and solder it all up again. So what we're going to do is put in the supplied battery holder, but to do that we've got to make a modification to that area, and the first modification is to put this link in here, which is the negative side of the board, which will now become the negative side of the board. And when we turn the board over, you can see here that the positive rail runs around to the negative side. We can't have that, so what we're going to do here is put a break in the right printed circuit board. So as you can see here, I've basically cut the right printed circuit board track in half, so now this side and this side are isolated. I'll just use this tool here, as part of the soldering toolkit to actually do that. What we'll do now is do a measurement and make sure that is isolated. So I've just set the multimeter up to ohms, do a check to make sure, yep, it's all reading right, got about 1.1 ohms for the leads. So if I go this side of the track to the other side of the track, you can see I've got open circuit. If I go to this side of the track, that should be a short circuit, and if I go from here to here, that should be a short circuit. So now we've got our positive side and our negative side for the batteries. We've got the battery holder in place. We've also got all the componentry attached to the board. We've put our link in, that's for the antenna. That's that link there, and as you can see it's part of the antenna system. And the next part we've got to do is to attach this wire there for the antenna. So what I'm doing here is scraping off the insulation coating that's on the wire. This will allow us to be able to solder the antenna to the printed circuit board. Alright, so we've almost got the project completed. The next part that we're going to do is clean all these solder joints to get the flux off, and you should do that after your soldering, or otherwise you'll end up with corrosion build up from the acids in the flux. The last pass that we actually did on this was the link. Then we put the antenna on. Now that's 5 centimeters long, which is specified on the drawings and the construction details. And we also put the pointer on, which is that there. So that's so you can adjust the dial to the frequency that you're after. So we've now got it set up, right? The actual unit here, we've got a power supply attached, and we've got the field strength meter, and we've run the cable up so it's nice and straight. So how this works is this little field strength meter is just letting us see that we're getting optimum output with reference to the unit is the FM transmitter. So what we do here is we just adjust the dial. You can see that we've got this powered up. We've got the right unit powered up as well, and we just adjust the frequency. You can see there we're starting to get some reading. The second LED is coming on, so we're getting closer to the tuning, and we've got the 3 LEDs lit up. Now if I go over that, right, you can see it's starting to fade off, so we're getting out of range. We go up on that, you can see you'll get to an optimum point where the brightness of the LEDs is maximum, then it'll drop off again, coming back up again. So you can see there it's working as it should work. So the reading on here is between 85 and 95 megahertz. That's basically where it was sitting at when we were using the radio to tune in with. And as you can see here, we're getting like good signal. You obviously lose signal as you move away because it's only it's got to be used close to the actual unit. Now if these if you weren't getting the 3 LEDs coming up, you'd have to find the optimum position, and then you'd have to play around with the tank circuit, right, to get the optimum power out. So these 3 LEDs down here are all bright and shiny.